These are solutions to Nelham's Math 222, exam number 4. Number 1, find the length of an arc with an angle of 45 degrees in a circle with a radius of 9 feet. So I have to use the formula S is equal to R theta. Theta must be in radians though. So 45 degrees is pi over 4. So 9 times pi over 4, 9 pi over 4 feet. Number 2, construct a right triangle with an angle theta, such that sine of theta is 1/4. Theta is in the first quadrant. Find all the remaining trig functions. Okay, so sine is opposite over hypotenuse. Then do your a squared plus b squared equals c squared. The adjacent will be radical 15. So sine of theta is 1/4. Cosine of theta is adjacent over hypotenuse, radical 15 over 4. Tangent is sine over cosine, so 1 over radical 15, the 4's drop out. And then the reciprocal, so cosecant of theta is 4, secant theta is 4 over radical 15, cotangent of theta is radical 15. Number 3, we have a tree, and you stand 100 feet from the base. The angle of elevation is 37 degrees. Give the height of the tree to the nearest whole number. Assume the tree grows straight up and the ground is level. So 100 feet, height we're looking for, 37 degrees. This is opposite, this is adjacent. So tangent of 37 degrees is h over 100, multiplied by 100. H is 100, tangent 37, and that comes out to be 75 feet. Number 4, between 0 and 2 pi, cosine of theta is radical 3 over 2. Cosine is positive in quadrants 1 and 4. Okay, radical 3 over 2 is always paired with a half. So that means the y-coordinate is either a half or negative a half. Okay, so that looks like 30 degrees, pi over 6. This is 30 degrees off of 360, so 330 degrees, 11 pi over 6. Number 5, sine x plus cosine x equals 1 between 0 and 2 pi. Okay, so subtract cosine x. Sine x is 1 minus cosine x. Square both sides. Sine of x squared equals 1 minus cosine x squared. Sine squared x equals 1 minus 2 cosine x plus cosine squared of x. Change sine squared to 1 minus cosine squared x. 1's cancel out. Add cosine squared of x to both sides. 0 equals 2 cosine squared x minus 2 cosine x. Common factor is 2 cosine x. 2 cosine x times cosine x minus 1 equals 0. So cosine x is 0 or cosine x is 1. Cosine x is 0. That would be pi over 2 or 3 pi over 2. Cosine x is 1. That's 0 or 2 pi. Okay, the number should be checked though. Okay, if I plug in 0, sine of 0 plus cosine of 0, 0 plus 1 is 1. That works. Sine of pi over 2 plus cosine pi over 2, 1 plus 0 equals 1. 3 pi over 2 does not work. Sine of 3 pi over 2 is negative 1. Cosine of 3 pi over 2 is 0. Negative 1 plus 0 is negative 1. And yes, we know 2 pi is going to work since 0 also worked. So the solutions are 0, pi over 2, and 2 pi, since we're asked to pick numbers between and including 0 and 2 pi. Okay, number 6, the amplitude. Amplitude is maximum minus minimum divided by 2. Maximum is 3, minimum is negative 1. So that's 3 minus a negative 1 divided by 2. That's 2. The period is 5 pi minus pi, which is 4 pi. Formula for the period is 2 pi over b. Switch these two. b is 2 pi over 4 pi, which is 1/2. Okay, and it starts up, which is the way the sine function normally works. And 0, 0 got translated to pi comma 1. So amplitude A is 2, B is 1/2. And the translation is pi to the right, 1 up. So 2 sine 1/2 parentheses x minus pi plus 1. 7, cosecant t is negative 3/2. T is in quadrant 4. Find all the other trig functions. Cosecant is negative 3/2. Therefore, the reciprocal sine of t is negative 2/3. Cosine squared t plus sine squared t is equal to 1. Over here, plug in negative 2/3. Negative 2/3 squared is 4/9. 1 minus 4/9 is 5/9. Cosine t is the square root of 5/9, which is radical 5 over 3. Cosine is positive if we're in quadrant 4. Right? So that gives me secant of t is the reciprocal of 3 over radical 5. Okay, and then we have it. And then tangent t is sine over cosine, negative 2/3 over radical 5/3. 3's cancel out. So negative 2 over radical 5. And flip it for cotangent, negative radical 5 over 2. So that gives us all the trig functions. Number 8, verify cosine x is sine x sine 2x plus cosine x cosine 2x. There's really nothing to do here, so all the action is going to be over here. So ordinarily, I'd put my barrier down the middle. Well, my barrier is going to be small here. I want to take up more space when we work on this. All right, sine x. Formula for sine of 2x is 2 sine x cosine x plus cosine x. Formula for cosine 2x is cosine squared x minus sine squared x. This comes out to be 2 sine squared x cosine x plus cosine cubed x minus cosine x sine squared x. Common factor is cosine x. Take out a cosine x, 2 sine squared x plus cosine squared x minus sine squared x. These two combined will leave me with sine squared x plus cosine squared x, which comes out to be 1. So cosine x times 1 is cosine x, which is what you were trying to prove over here. And number 9, cosine of arc sine 3/5 plus arc cosine of 4/5. So call that A, call that B. So ultimately, I'm trying to find cosine of A plus B, which is cosine A cosine B minus sine A sine B. If A is arc sine 3/5, that means sine of A is 3/5. Draw myself a triangle. Sine is opposite over hypotenuse. We have a 3 and 5. That means this is 4, 3, 4, 5 triangle, which means the cosine of A is 4/5. B is arc cosine of 4/5. That means cosine of B is 4/5. So here's B. Cosine is adjacent over hypotenuse. So that means the opposite side must be 3, 3, 4, 5. So sine of B is 3/5. Right, so now I just plug everything. So cosine of A plus B, cosine A is 4/5. Cosine B is also 4/5 minus sine A 3/5. Sine B is also 3/5. So that's 16 over 5 minus 9 over 16 over 25 minus 9 over 25, 7 over 25. Finally, 10. Alpha is 38 degrees, beta is 81, C is 10. Find all the remaining parts of the triangle. Well, we're given 2 angles, so that's pretty easy. Just find the third angle first. All right, so I drew myself a triangle. A, alpha, little a, capital B, beta, little b, little c, big C, and gamma. So gamma is 180 minus 38 minus 81, 61 degrees. And then I'll use the law of sines. Sine of 38 degrees over A, sine of 81 degrees over B, sine of 61 degrees over 10. So temporarily ignore this. Cross multiply here. That times that times that. B sine of 61 degrees equals 10 sine of 81 degrees. Divide both sides by sine of 61 degrees. So B is 10 sine 81 degrees over sine of 61 degrees, 11.29 for B. And do the same thing for A. Ignore the middle fraction. So A times sine of 61 equals 10 times sine of 38. So here we are. Divide both sides by sine of 61, and it comes out to be 7.04. So summarizing the result, A is 7.04, B is 11.29, and gamma is 61 degrees. So these are the solutions to test number 4.